In this video, I am going to go over 5 sample math test questions, and these questions pertain to the HISET math test. However, these questions will help you with the GED math test and other standardized math tests as well. So let's jump into this. Question 1, it states, the graphs below, these graphs, the graphs below show the total value in US dollars of the imports and exports of country W with its 3 trade partners, countries X, Y, and Z. So these graphs are showing country W's trade partners. So if you notice, here's the value of the imports, X, Y, and Z. This is country X, country Y, country Z. And the value of the exports in US dollars, country X, country Y, country Z. And it's only showing, these graphs are only showing the trade partners with country W. That's why country W doesn't show up on these graphs. So you might want to reread this again to make sure you got that. Now, let's go to the actual question. It says, what percent of country W's total imports was from country X? So, I like this. So we're clear that this is the question. So what percent of country W's total imports was from country X? So we're dealing with, highlight this piece too, we're dealing with total imports, right? Which is right here. Not the exports, just the imports. So we're just looking at this graph. And we want to know what percent of country W's total imports was from country X, which is right here. Now, when you're thinking of percents, you want to think the following. Hopefully this helps. You want to think part over total. It's one way to look at it. A percent is a ratio. It's going to be a comparison between two things. So let's see. What are we trying to figure out? It says, what percent of country W's total imports? So what I need to do is figure out on the bottom the total imports from country W. And I'll put that on the bottom. Well, what do you think that would be? Again, we're not dealing with the exports here in this problem. We don't even need this. How would I figure out the total import for country W right here? Because it says country W's total imports. That's what this means, this total. How do you think I'd figure it out? Well, I mean, if you go back to the original question, it says the graph below shows the total value in US dollars of the imports. We're just dealing with the imports, so I'm not even going to worry about exports. Of the imports of country W. So if I add these 3 bar graphs up, that's one way to look at it, that'll give me the total imports for country W. So I need to just add up the 3 trade partners of X, Y, and Z to get the total just for the imports. So let's see. This says here, dollars and millions, 40. So this really represents 40 million. So this is 0, 10 million, 20 million, 30 million, 40 million, 50 million, and so on. But I'm not going to write it out completely. I'll just put 40 million. So let's say here's X. That's 40 million from right here. If I read this bar graph. So X is 40. I'm doing the total. Plus Y, which would be 80 right here. It's really 80 million. I'm just going to write the 80. That's fine. That'll work. And then Z is here. That is also 40 right here. Okay, and what's the part? It says, again, let's look at the question. This is tricky. It says, what percent of country W's total imports was from country X? So country X is the part that I'm looking at, which is right here again. Here's country X. So the part is 40 for country X. And I'll put this piece on top. And I'll just simplify this ratio. I'll come down here. So it's 40 divided by 40 plus 80 plus 40 on the bottom. Well, let's see, that's 160. And then you can use a calculator to go 40 divided by 160. I don't have my calculator. Let me see, do I have my calculator here? Yes, I do. Here, you'll have access to a basic calculator, so you can just go, this means division. So you'll go 40 divided by 160. That equals 0.25, which equals 25%. There you go. So the answer is B. Let's go to the next question. Question 2, it says an artist has all her paintings framed with a 3-inch wide border. She has a painting to be framed that is 1 foot by 1.5 feet. Which of the following measurements represents the perimeter of the painting with the border? So let's highlight the key parts of this question. Which of the following measurements represents the perimeter? Hopefully you remember perimeter is the distance around. So which of the following measurements represents the perimeter of the painting with the border? Now again, as a reminder, perimeter measures the distance around. Area represents the space inside. So keep those two separate. And let's go to the painting here. So if they were asking what is the perimeter of the painting only, that would be the distance around the painting, this distance right here. But they're asking for the perimeter of the painting with the border. So here's the border here. So the perimeter of the painting with the border includes the distance all the way around from here to here to here to here. So that's what we need to figure out here. And what we're going to do is just simply add up everything here. And a couple things you want to be careful of is this is in inches. That's inches. And this is in feet. All of this. So you're going to have to change some things here to make sure that you're using the same units. So if you remember, 1 inch, I apologize, 1 foot equals 12 inches. Now, by the way, you don't need to remember this. You'll have a formula sheet. This is on the formula sheet. So I need to make some conversions here. So this is on the formula sheet. 1 foot equals 12 inches. So here we have 1 foot, right? Let's just change this to 12 inches. This equals 12 inches. I'm going to put 2 little marks like that. These marks up here, it's not an 11. It just means inches. I just don't have room to write it out. Let me just write it out as inches. That looks like an exponent of 11. So this is inches. So now this is in inches, this is in inches, this is in inches. I'm converting everything to inches. This is in inches, this is in inches. I need to convert this little piece to inches. So what do you think 1.5 feet? What would that be in inches? Think about this. Now 1 foot is 12 inches, right? But I want 1.5 feet. Hopefully you know that 0.5, just this little piece right here. This little piece right here, 0.5 is a half an inch. 0.5 is like 50%, right? Let's think about this for a second. Sometimes we skip over these concepts. They're a little tricky. 0.5, right? Well, you can tack on a 0 here. It doesn't change anything. 0.5 is the same as 0.50, right? These are the same thing. Think about it. If I had money, this would be 50 cents, and this would be 50 cents. It's like half a dollar. So 0.5 is the same as a half. So I'm going to rewrite this as 1 1/2 feet. Same thing. 1 and 0.5 is the same as a half. Well, we know 1 foot, right? We've already established that 1 foot is 12 inches from right here, right? What is a half a foot going to be? What would a half a foot be? Well, if a complete foot is 12 inches, right? Well, a half a foot would be half of 12. And half of 12, you just cut it in half, would be 6. So 1.5 feet is the same as 1 1/2 feet. So 1 1/2 feet would equal 18 inches. Hopefully that made sense. These are confusing concepts. So this piece here is 18 inches. And now we have everything in the same units. 3 inches, 12 inches, 3 inches, 3 inches, 18 inches, 3 inches. Everything's in inches. It's going to make it easier. I'm going to erase this piece right here. Now what we need to do is just add everything up here. Boom, boom, boom. It's like I'm walking around this painting with the border here. Now, I'm going to put in some extra stuff here. If we think about it, right? If this is three inches here, then I can just move these markings up here, right? Here, I'm just moving this marking up. This would have to be 3 inches too. I'm not going to write inches in there. And if this is 18 inches, right? Move this marking up and this marking up. This is also 18 inches, right? So from here to here is 18 inches. So from here to here would be 18 inches as well. And if this is 3 inches here, this up here, right? This length here is the same as this length, right? That's what I'm getting at. This is 3 inches, then this is 3 inches, right? Again, if this is 18 inches from here to here, right? I put these markings up, right? This is 18. Then this also would have to be 18. Just transferring that up. And so same thing here. Then I can do that across, right? If this is 3 inches here, from here to here, this is 3 inches. Then if I move these markings over, this and this would be 3. I'm just going to continue that process. Again, there's other ways to do this. So move this marking here. So if this from here to here is 12 inches, then from here to here is 12 inches. And what do you think this piece would be right here, from here to here? If this is 3, then this is 3. And now it just comes down to adding up all the numbers. Again, there's quicker ways to do this, but I want to show you how I do it. You might know a quicker way, and that's fine. So I'm going to highlight these pieces right here. Let me put these in yellow. So I'm adding up. It's like, let's say I start right here, and I'm just adding up all the numbers all the way across. So I'm taking 3 plus 18 plus 3 plus 3 plus 12 plus 3 plus 3 plus 18 plus 3 plus 3 plus 12 plus 3. Once I add those up, I will have my answer almost, okay? We got to be careful because I converted everything to inches. It makes it easier. So let's do that. Watch. So add these up. You'll have access to a basic calculator. So I'm going to start with my 3 right from here, plus 18 plus 3. Again, there's quicker ways to do this. So I've added these up, and I just keep going and add up the rest of the numbers. Plus, right here now, plus 3 plus 12 plus 3 plus 3 plus 18. Right here now, plus 3 plus this 3 plus 12 plus 3. 84. Inches, right? Inches. Again, I started here. Keep track. I started with this 3 and I just worked my way around. You can double check that. I get 84 inches when I total that up. So this is my answer, 84 inches. Uh-oh, there's a problem though. Well, hopefully you see the problem. Our answer choices are in feet. And my answer is in inches, so I need to change 84 inches to feet. Well, we can do this. I'm going to write the 84 inches down here. Okay. This was our answer. Now, I'm going to use this piece here. Remember, 1 foot equals 12 inches, right? Again, that'll be on your formula sheet. So let's just make a table. That's going to make it easier for you. So feet, inches. Just making a table. So again, we know that 1 foot, right? 1 foot equals 12 inches. So what would 2 feet be? Well, if 1 foot's 12 inches, 2 feet are 24 inches, right? Hopefully you can see that, right? I'm just doubling the 12 because 1 foot's 12, 2 feet's 24. I'm just adding 12 each time. So what would 3 feet be? Just adding in 12 inches each time. So 12 plus 12 is 24. 24 plus 12 is 36. So hopefully you can see that. 1 foot's 12 inches. So 2 feet would have to be double that, or just add 12 each time, right? 12 plus 12 is 24. 24 plus 36, and just keep adding 12. So hold on. Maybe we can eliminate some choices right here. We want to know what 84 inches are, right? Right? Well, we're just going to have to keep going until we get to 84. And hopefully you can see you can eliminate a couple answer choices, right? It can't be B because 36 inches is 3 feet and we want 84 inches. So I can eliminate B, and for the same reason I can eliminate A. A is too small. Let's just keep going. What would 4 feet be? Just add 12 to 36 because I'm adding 12 inches each time. So 36, 46, 48. So 48 inches is 4 feet. Let's keep going. Let's keep going. Let's go up to 8. What's 5 feet equal? Just add 12 to this, 48, 58, 60. So 60 inches is 5 feet. And we want 84 inches. That was my answer right here. So it can't be C because 5 feet is 60 inches, not 84 inches. Now I'm just using the process of elimination. Let's do 6. That would be 72, right? 7, just add 12 to 72 would be, well, hold on. I can eliminate D now, can't I? Because 60 inches is 5 feet, and I want 84 inches. So hopefully you can see D's gone. Let's just keep going, see if we can get the right answer. 7, let's see, what would 7 be? 72, 82, 84. Boom, right here. It's right here. 7 feet is 84 inches, right here. Boom. So 80, or another way to look at it is 84 inches, which was my answer, is 7 feet. So it's got to be E. That's one way to go about this. Let's go to the next question. Time a coin is flipped, it has a 50% chance of landing on heads and a 50% chance of landing on tails. The coin is flipped 3 times. What is the probability it will land on tails all 3 times? Let's highlight our final question. I find probabilities one of the most difficult things to explain, so I'll give it my best shot here. So you want to know, you're flipping a coin, and you want it to land tails 3 times in a row, right? So if it lands on heads the first time, it's not going to work. This is actually called a dependent event. And I am going to show you the quick way to do it at the beginning. And then I'll show you the long way to do it so you can see it. So I want it to land on tails all 3 times. Tails, and then tails again, then tails again. Well, for this to happen, first time I flip the die, I need a tails. If it comes out to be a heads, it's not going to work. That's why each roll is dependent on the previous roll for this to work out. And when you're dealing with dependent probabilities, you simply multiply. Now, that's all you got to do. There's a 50% chance, right? So for this to happen the first time, my eraser, put the comma here. So I need it to be tails, tails, tails. So I'm flipping a coin. For it to land on tails the first time, I have a 50-50 chance, right? 50-50 chance. Hopefully you remember that 50% is the same as 1/2. I explained that in terms of money in the previous part, but that's a good thing just to put in your memory. 50%, same as 1/2. So for it to land on tails, right, the first time, I have a 50% chance, or I want to write that as 1/2. Then to land on tails again, I'm flipping a coin. It's heads or tails. It's a 50% chance. And then again, here, to land on tails, it's a 50% chance. That's the probability each time. And since they're dependent on each other, I multiply. So I'm basically just multiplying 1/2 times 1/2 times 1/2. Well, do you remember how to multiply fractions? You just take top times top times top, which is what I'm going to do real quick. So you go 1 times 1 times 1. And then bottom times bottom times bottom. 2 times 2 times 2. And that's going to equal, well, 1 times 1 is 1, right? Times 1 again. Whenever you multiply by 1, you just get 1 back. So in other words, 1 times 1 times 1 is just 1. Then 2 times 2 here, well, 2 times 2 is 4. And 4 times this 2 is 8. That's your answer, 1/8. It's going to be A. Again, probabilities are tricky. When the events are happening in a row or they're dependent on each other, you're going to need to multiply the probabilities, and that's what I did. Now, why does this work? Another way to look at this is you can use a probability, you can use a, can't remember the name, it's called kind of like a tree diagram. And maybe this will help you see it better if you want to understand why, or maybe that explanation previously was good. But we're flipping a coin, right? So we have some coin. And I'm going to be flipping it. The first time I flip it, I'll just make a little tree like this, right? I have a 50-50 chance it's either going to land on heads or tails, right? Heads or tails. Now, I flip it again. So let's say it lands on heads the first time. When I flip it again, this is the second flip, right? This was the first flip here. Now I'm flipping this one again. It's again, it's either going to be heads or tails, right? Now, same thing on my first flip here. Let's, again, let me just re-explain this real quick. On my first flip, I flipped a heads. Then I flipped it again, and I either get a heads or a tails. What if on my first flip I get a tails? Well, that's this part of the tree diagram. And then I flip this again. Again, it could be heads or tails. Now, we're over on this part here. This was our second flip. Now, let's say it came out to be a heads here on the second flip, and I flip it again, because remember, I'm flipping it 3 times. So, on the second flip, if it lands a heads, then I flip it again. Again, it could be heads or tails. And same thing here. On the second flip, if it's a tails, it could be heads or tails. And I just continue this. This could be heads or tails. And this could be heads or tails. Now I'm finished with my probability tree because it said we're flipping the coin 3 times, right? This was my first flip, second flip, third flip. So how many total possible outcomes are there? Well, you're going to see there's 8. Watch. Let me show you. I mean, I could have flipped a heads, heads, heads. See how I'm reading this tree? Heads, heads, heads. So let me write that down. We could have heads, heads, heads. From right here. Heads, heads, heads. Or I could have a heads, heads, tails. See? Heads, heads, tails. I'm just writing it this way. I'm not sure if my notation's right. Well, what do you think the next possible outcome is? Well, you can start seeing this quick. We had heads, heads, heads here. Heads, heads, tails. Now I could go over here and go heads, tails, heads, right? Right here. Look, I'm looking at this one. Heads, tails, heads. Do that. So let's just make sure we got this. First I went heads, heads, heads. I wrote that here. Heads, heads, tails. Then and I wrote that here. Then I got heads, tails, heads. I did this one. What do you think the next one's going to be? The next one could be heads, tails, tails. That would be the next one, right? Heads, tails, tails. And we just keep going. Can you see the rest of them? I'm going to write the rest down here. So I got to keep track of this. Here we had heads, tails, tails. That was here. Heads, tails, tails. And now we're done here with this one. Now we got to go down to this one. Hopefully you can see that. This would be tails, heads, heads. I'll write that below here. Tails, heads, heads. Right? Tails, heads, heads. And then tails, heads, tails. And then I did this one, tails, heads, tails. So now tails, tails, heads. And then tails, tails, tails. This is the one I wanted, right? This is the outcome I wanted right here. And I know this is longer, but I think it's important to understand this stuff. This is the outcome I wanted right here. I wanted it to be tails 3 times in a row. The coin will be flipped 3 times in a row. What is the probability it will be on tails all 3 times? Right here. Tails, tails, tails. That's the one I wanted. How many total possible outcomes were there? Let's see, the total possible outcomes are, we could have had a heads, heads, heads. That's one possible outcomes, or a heads, heads, tails. That's 2, 3, 4, 5, 6, 7, 8. So with probabilities, you write the total possible outcomes on the bottom, and there's 8. 1, 2, 3, 4, 5, 6, 7, 8. And which one came out the way I wanted to? Which outcome was tails, tails, tails? Well, there's only one right here. This was the only one that came out tails 3 times in a row. The rest didn't. This, for example, came out, I spun it the first time and it was a tails. The next time I spun it, it was a heads. The next time it was a tails. The only possible outcome that gives us tails, tails, tails is this one. There's only one of them. The others don't work, so that goes on top. And that's a 1 out of 8 probability, which was A. So that's the concept behind what I told you at the beginning. I know it's long, but that's how you learn math. If you understand the concepts behind what you're learning, it will really help you. Let's go to the next question. Question 4. It takes one bag of chocolate chips to make 72 cookies. How many bags does it take to make 18 dozen cookies? Well, let's see. Let's highlight this here. Bags. Does it take to make 18 dozen? Well, you need to know that 1 dozen equals 12 cookies. Now, this is something you'll just need to memorize. I don't believe this conversion is on the formula sheet. So 1 dozen is 12 cookies. So let's keep that written down. How many bags does it make to take? How many bags does it take of chocolate chips does it take to make 18 dozen? So if 1 dozen is 12 cookies, what would 2 dozen be? Just be double this, so you just add 12. This would be 24 cookies. What would 3 dozen be? Well, you just add 12 each time because 1 dozen is 12 cookies. 2 dozen is 24 cookies. So what would 3 dozen be? Just keep adding 12 each time. So that would be 24, 34, 36. Well, you can keep going until you get to 18. That's going to take a while. Hopefully you can see the pattern. What do you, based on this pattern here, right? I took this out to 18 dozen, because that's what it's asking for. What do you think 18 dozen would be? You pause the video and see if you can figure that out. Well, hopefully you came up with, hopefully you saw a relationship here, right? Because one way to look at this is that there's a pattern here. This is 12 times 1, right? Because 12 times 1 is 12. This is 12 times 2, which is 24. So this is 12 times 3, which is 36. So this would have to be 12, right? I'm just taking 12 times 1, 12 times 2, 12 times 3. So this would have to be 12 times 18. And that would give you 18 dozen cookies. We're not done yet, obviously. I wish we were, but we're not. So 12 times 18 would be 216 cookies. So this would be, hopefully you got 216 cookies. So that's what the question comes down to. I'm going to erase this. Instead of saying 18 dozen, I'll just rewrite that as 216 cookies, because 18 dozen cookies is 216 cookies. Let me erase all this now. Basically, the question now comes down to this. It takes 1 bag of chocolate chips to make 72 cookies. How many bags does it take to make 216 cookies? Well, we can just make a table here. Now that I've got that, I love tables. I'll call this bags cookies. Really, I should label this bags of chocolate chips. This is bag of chocolate chips, and this is the number of cookies. So let's go back here. It says 1 bag of chocolate chips makes 72 cookies. So if I have 1 bag of chocolate chips, I can make 72 cookies. What if I have 2 bags of chocolate chips? How many cookies could I make? Well, I can make another 72, right? So with 2 bags, I could make another 72. I just go 72 plus 72, which would be 144. So if I have 2 bags of chocolate chips, I can make 144 cookies. Well, the question is this: how many bags does it take to make 216 cookies? Well, 2 bags give us 144. 2 bags of chocolate chips, it does not give us 216. So A is gone. You can eliminate that. I'm thinking my answer is going to be B here, but let's go. Let's go to 3 bags. So if I have 3 bags of chocolate chips, how many cookies can I make? What do you think? Why don't you pause the video and see if you can get it? Welcome back. Hopefully you can see that each time you add a bag of chocolate chips, you can make an additional 72 cookies. So I'm just gonna, to get 3 bags, I'll just add 72 cookies to the 144. Right? 144 plus 72 is 216. So 3 bags, if I have 3 bags of chocolate chips, I can make 216 cookies, and that's what I want to know. That was my question. How many bags does it take to make 216 cookies? It takes 3 bags. So again, each time you add a bag of chocolate chips, the number of cookies you make increases by 72. So I was just adding 72 plus 72 is 144. 144 plus 72 is 216. And that's why B is my answer. 3 bags make 216 cookies. And I move on to the next question. Question 5. Melody is making a spinner with a 12-inch diameter for a game. She will divide the following spinner into sections, shown here. What is the area in square inches of section C? This is a tricky one. So let's look at it. Basically, I have this whole circle right here. And I want to find the area. Area is the space inside of section C. In square inches. What? Okay, but basically here's section C right here. I want to find the area of this section right here. So the first thing I'm going to have to do is find the area of the whole circle. That's what I'm going to need to do. And you will need to know that the formula for the area of a circle is pi times radius squared. Now, this will be on your formula sheet. This will be on your formula sheet right here. So you don't need to memorize that. Well, if you notice in my answer choices, they leave the pi symbol in there. They just leave it in there. A lot of times they do that. I mean, pi equals 3.14, but I don't even need to really know that. I'm just going to leave the pi symbol in my answer. So let's see if we can figure out the area of the whole circle. So to find the area, we need to, of the whole circle first, we need to figure out the radius. This R stands for radius. Give us the diameter. It's 12 inches. This is Melody is making a spinner with a 12-inch diameter. Right here. So real quick, just a quick refresher. If you have a circle, the diameter is the distance. It's the line segment that goes through the center of the circle, right here. And it goes from edge to edge. The radius is half the diameter. So this whole thing's the diameter. The radius is this piece right here, from here to here. It's half the diameter. So If you can remember that the radius is half the diameter, you'll be in good shape. So the diameter is 12 inches. The radius is half of that. Well, I take half of 12. One way to take half of something is divide it by 2. So if the diameter is 12, 12 divided by 2, or half of 12, is 6. So the radius would be 6 inches. Well, let's go ahead now and find the area first of the total circle here. So the area equals pi. Just bring this down. I mean, I'm just going to bring this down each time. Don't sweat this too much because it's already in our answer choices. So pi times the radius. So I need to replace the radius with something. It's 6. From up here, we figured that out. So the radius is 6 squared. So the area of the whole circle is, bring down your pi symbol, and hopefully you remember 6 squared means 6 times 6. Remember, exponents mean repeated multiplication. So I'm taking the 6 and multiplying it by itself 2 times. 6 times 6 is 36. So the area of the whole circle is pi times 36. There's really a times sign here. I can reverse this. Instead of saying pi times 36, I can say the area of the whole circle is 36 pi. You can just flip these around. So this is the total circle right here. The area of the whole circle. The whole circle is 36 pi. Well, I don't want the whole circle. I just want section C. I just want this piece. Just want this piece here. So this is not my answer. Therefore, I can get rid of B. Hopefully you can see that. I can get rid of B. Because 36 pi represents the area of the whole circle, and I just want this section C. So my answer has to be less than 36 pi. And A's gone too, right? A doesn't make any sense because if it's 144 pi, and I know that my answer has to be less than 36 pi. Again, don't let that pi symbol confuse you. Really, my answer has to be less than 36. And 144 is bigger than 36, so A is gone as well. And now you have a better chance of guessing. It's either going to be C, D, or E. If you need to guess at this point, that is perfectly okay, because it's going to get a little confusing at this point. So I'm going to rewrite this piece. 36 pi. I'll erase this part of it right here. Let's do this and erase this. So the area of the whole circle is 36 pi, but I just want this piece here. And hopefully you see that this piece here is 45 degrees. Also, hopefully you remember that a full circle is 360 degrees. I mean, you could add up 90 degrees plus 150 plus 75 plus 45, and you'll get 360. Or if you ride a skateboard, if you've ever done a 360, that's a full circle. So I'm going to think of a kind of a ratio here. And remember, ratio, I'm going to think of part over total. Let's think about that for a second. A full circle, the total part is 360 degrees. But I just want this piece, 45. So basically, the 45 out of 360 is the part of the area that I want. And the total area was 36 pi right here. So what I'm going to do, let me just write this up here. I'm going to take the this section, 45 out of 360. That's the part that I want times the total area of 36 pi. Again, I'm just bringing my pi symbol down. You can really, if you wanted to make it easier, you could just eliminate the pi's on all of these. You really could and not even show it and just pretend it's times 36. But I didn't do that from the beginning, so I'm just bringing down my pi symbol each time. So what I'm doing is taking this section, 45 out of 360, times the total area. This was the total area, 36 pi. But let's just change this 45 out of 360 to a decimal. So it's 45 out of, or divided by, this means divided by 360. And that equals 0.125. Again, you have access to a basic calculator. So I'm going to replace this 45 out of 360 with 0.125. Times 36. Really, just this would be good, but I'm just bringing down my pi symbol each time. And let's just do this piece right here. 0.125 times 36. Times 36 equals 4.5. And that's my answer, the one with the 4.5. You can bring down your pi symbol. You could have really just excluded it from all those calculations as well. So the answer is C, 4.5 pi, right here. That's your answer. Now again, you might have wanted to guess at this point, this is a tough problem. Hopefully it made sense to you, and hopefully these 5 sample problems will improve your test scores on the HISET math, GED math, or any standardized math test you're taking. Thanks a lot for watching my video so much. I really appreciate it. Have a great day.